Hi everyone, today let us learn saturated and unsaturated compounds. There are single bonds between carbon atoms. Saturated compounds are alkanes and cyclic alkanes. They dissolve in nonpolar solvents because alkanes are nonpolar molecules. They do not give addition reactions, hydrogenation reactions. So we all should understand that whenever we talk about carbon bonds, valency of carbon is 4, and all saturated compounds have single bond. So when you take carbon and another carbon atom, between them there is a single covalent bond, and this is true for all types of saturated compounds. And some of the types of saturated compounds could be alkanes and cyclic alkane. Now coming to certain physical properties, they dissolve in non-polar solvent, because we all know saturated compounds are non-polar molecules, and polar solvents always are soluble in polar solvents always dissolve polar compounds. Like for example, if we take NaCl, NaCl is dissolved in water because both of them are polar. Similarly, when we talk about saturated compounds like alkane, then again they are soluble in polar solvents like benzene, ether, and so on. They do not give addition reaction or hydrogenation. So we all know for addition and hydrogenation mainly there should be unsaturation, that is double bond or triple bond, which is absent in saturated compounds. Hence they do not give or they resist addition reaction and hydrogenation reactions. Now let us understand, let us try to draw the next topic would be to draw saturated compounds. So let's say they have given methane. So we will understand how to write the structural formula for methane. So we all know, students, carbon atomic number is 6, and when we talk about valency of carbon is 4. That means every carbon atom can form 4 bond around itself. And hydrogen on the other hand, hydrogen atomic number is 1, valency of hydrogen is 1. So it means that carbon, if I take carbon as the central atom, so around carbon there can be 4 bonds, and these 4 bonds would be hydrogen. So this is the meaning of, or this is how we write the structural formula for methane. So this is the simplest hydrocarbon. Methane is the simplest hydrocarbon. So next let us go to the second one, that is going to be ethane. So ethane molecular formula is C2H6. So how to draw the structural formula for methane? Again, we are considering, since look at the carbon atoms. How many carbon atoms are there? 2 carbon atoms. So first let us write 2 carbon atoms and put a single bond because they are saturated compounds. Then we also know that valency of carbon is 4. So it means that around carbon, every carbon atom, I should be writing 4 bonds. So again on the next carbon atom, there should be 4 bonds. So now totally there must be, now these bonds that I have written, this is incomplete structural formula because I have to write the remaining element, that is hydrogen. And how many hydrogens are there? 6. So I will write 6 hydrogen atom. In these, that is, it's going to complete the structural formula. So now if you count the number of carbon atoms, there are 2 carbon atoms, and when you count the number of hydrogens, there are 6 hydrogen. So this is how we write the second member of the saturated compounds, that is ethane. So whenever you write the structural formula, make sure that every carbon atom is having 4 bonds around itself. So that is how we have to confirm the structure. Now similarly, next let us go to the next molecule, the third member of the saturated compounds, that is propane. So now let us look at the number of carbon atoms. It is C3. So first let me write down 3 carbon atom. And how many hydrogens are there? There are 8 hydrogen. that doesn't matter. Now first we only have to focus on valency. So make sure there are 4 bonds around each carbon atom. Now we will write the remaining element, that is going to be hydrogen, in all these places. So now totally when you count the number of carbon, there are 3, and when you count the number of hydrogen, there are 8. So this is how we write down the structural formula for propane. Now in general, so there is a general formula for alkanes. So the general formula for alkanes is CnH2n plus 2. So you go on substituting N value. So for methane, N is going to be number of carbon atom. So for the first simplest hydrocarbon, that is methane, what is the number of carbon atom? 1. So if I substitute in place of N 1 and then H 2 into 1 2, 2 plus 2 4. So it's nothing but equal to CH4. So CH4 is methane. Similarly, the second, if I substitute CnH2n, N if I take as 2. Okay, N if I take as 2, then what will be the formula now? The formula will be C2, 2 2s are 4 plus 2 6, C2H6. So that is ethane. So like this, students, if you go on substituting N is equal to 3, then we get C3H8. N is equal to 4, we get C4H10. N is equal to 5, C5H12. N is equal to 6, C6H14. And also one more I have included, which is not there in the syllabus, but just to be on the safer side, we will learn for N is equal to 7. That is going to be C7H16. That is nothing but, we can write here, I will write here, N is equal to 7 if I take and substitute C7H, 7 2s are 14 plus 2, 16, C7H16. So this is how we write the general formula or general formula for alkane, CnH2n plus 2, and these are all the molecular formulas for the subsequent saturated compound, that is alkanes: methane, ethane, propane, butane, pentane, hexane, heptane. Now when you look carefully, we can also understand that every next member of the alkane differ by CH2 unit. We'll take an example. Ethane, what is ethane? Molecular formula C2H6 minus methane CH4. So if I subtract, I can understand that this ethane is differing from methane by CH2 unit. That is, for methane, if you add CH2, it becomes ethane. Similarly for ethane, if you add CH2, it becomes propane. Similarly for propane, that is C3H8, if you add CH2 unit, it becomes butane, and so on. Okay, so every member of the saturated compounds, as every member of the alkane, methane, ethane, propane, they differ by CH2 unit. So because they differ by CH2 unit, students, also their physical properties also vary. Example, melting point, boiling point, density, viscosity. So all these parameters, physical parameters also differ because their molecular mass also goes on increasing. So if you take methane molecular mass is higher than ethane, and so on. So this is about the saturated compounds. Thank you.